The future is watching. Welcome to Opcode Virtual Summit.
Hi, Matt. Thanks a lot for having me. Hi. So, as you said, we are going to discuss about the automation of Active Directory labs in Azure. And as you said, it's actually pretty confusing because there is a project from Azure which is called Azure Active Directory, and it's not at all Active Directory in Azure. So maybe we'll discuss it a bit later. All right. Can you see my screen? Okay. Great. So we're going to discuss some use cases for Active Directory labs, because first, why do we want to build some? Then we're going to check out some tools from the DevOps ecosystem. So things like Terraform, Ansible, and Packer. And we're going to see how they can help us build this kind of labs. And then I'm going to talk about ADAS, which is a tool that I've been working on in the past few weeks. So a few words about me. I'm French, as you can hear from my accent, and I'm living in Switzerland, working in the security team of NextThink. So about labs, I really love labs, and I think a very well-known French scientist, he also loved them. His name is Louis Pasteur, and there's a quote that I love from him, and the quote is, "Without laboratories, men of science are soldiers without arms." And the reason why I like this quote is that it's also very applicable for me, because I found out that to be able to learn technology, I really need to be able to experiment with it, to break things in a way that that is fine. So in this context, labs are really very great resource to learn. So in the context of specifically Active Directory labs, some use cases that I had personally, and that I think a lot of other people have as well. The first one is test and practice some offensive tools and techniques. So things like, if you dump the local administrator credentials on a workstation, can you actually do some lateral movement on another workstation? Can you do it on the latest Windows 10? Can you do it if you have Defender installed? And all these kind of questions that it's very hard to answer if you don't actually test it on a real or simulated environment. Something else, testing tools. You probably heard about Bloodhound. It's a very nice tool which allows you to have some attack graphs in an Active Directory environment, but it's a bit pointless if you just run it on your laptop. So it's much more interesting if you have a domain environment with groups, a lot of workstations, local administrators that are connected in different places, and these kind of things. Another really valid use case is also to be able to build some detections for common attacks and techniques. So for instance, if you are trying to detect lateral movement, okay, maybe you are going to run ps exec on a bunch of workstations, and you are going to look at what events do you have on your workstations, what events do you have on your domain controllers, and how can you build a detection from that. Similarly, if you want to detect what happens on a machine when Windows Defender gets disabled, you're going to be able to find this as well with a lab. And finally, it's also super useful, at least for me, when you want to just try some Active Directory and some Windows features. For instance, there is a new feature in Windows, which is the protected users group, and it allows basically privileged users not to expose their credentials if they connect on a remote machine. So it's a very nice feature, but it's also very nice to be able to test it. So you take a user, you connect via RDP to a remote machine, and then you can run Mimikatz or volatility or something like this to be able to check that the credentials are actually not there. So to validate the features of Active Directory of Windows, and some other common things like, how do you enable AppLocker with a GPO? Can you bypass it if you run PowerShell with this flag, or this kind of things? So now we have the use case for why we want Active Directory labs. So now let's check out how we can build Active Directory labs. We're just going to lay down a few simple requirements. So one of them is going to be, we want a Windows servers as one Windows server as a domain controller. We want multiple Windows 10 workstations, multiple because it's nice if you want to test lateral movement. And we want the lab to be relatively easy to spin up and to destroy, because typically the use case is going to be, you want to try something, you spin up the lab, and once you're done, you just shut it down. So in this use case, we also want it to be relatively fast to spin up, as in if it takes 6 or 10 hours, it's not going to be doable. So now we know that we want to build the lab. How, like, where do we build it? We have the option to build it locally on our laptop. We can use tools like Vagrant, VMware Workstation, VirtualBox, vSphere, Proxmox, if we want to have some more enterprisey things. And we also have the option of a public cloud. So Amazon Web Services, Azure, Google Cloud. So for my personal use case, I don't really want to be tied to my hardware, especially because I think as of today, I have approximately 4 gigs of hard drive free on my machine. So I really don't want to have to free up 200 gigs for spinning up a lab. So in my use case, I'm going to discard the local option, and we're going to look at the public cloud option. So we have Google Cloud, AWS, and Azure. And the main issue with Google Cloud and AWS in this context is that you cannot spin up, as far as I know, Windows 10 machines, except if you bring your own license. So basically, you need to spin up a Windows 10 image that you build yourself, and then you have to pay for the license. You have to enter the license key and these kind of things, which is not really practical in the use case where we just want to be able to spin it up easily and for a short amount of time. So we're going to focus on Azure for this specific use case. So Azure supports Windows 10, Windows Server 2019. And the main downside that I saw from my experience with it is that the API is a bit slower, and creating the virtual machines takes quite a lot of time. So now we know what we want to build, and we know where we want to build it. So now we're going to check out how we can build it. What are the tools that we're going to be able to use? So there are two main things that we want to do. First one is to create the resources in Azure. We're going to have to create virtual machines, virtual networks, network security groups, public IPs, and these kind of things. And the second thing is we want to be able to configure the virtual machines that we spin up. For instance, we have to create a Windows domain. We want to have the workstations join it. We want to install some software and these kind of things. So there are multiple ways to do it, obviously. In this case, we're going to use Terraform for creating the resources. And we're going to use Ansible to configure the virtual machines once they are created in Azure. So both of these tools, they are tools that allow you to declare your configuration and your infrastructure in a declarative manner. So instead of having something like a PowerShell script where you write imperative code, in this case, it's more declarative code. And then the tool is going to be able to do the right actions depending on the state that you want to have. This is an example Terraform code where we create a resource group in Azure in the West Europe region and a virtual network 10.0.0/16. And so as you can see, it's kind of readable. It's the HCL language from HashiCorp. So once we have this, and obviously it's going to be a bit more complex, we just have to log into the Azure CLI. Then we can just configure the Terraform provider for Azure. We're just going to tell Terraform how to reach Azure, what version of the module to use. And then we hit Terraform apply, and Terraform is going to create the resources in Azure for us. And Terraform also supports a bunch of other providers, some public cloud providers like AWS, but also a lot of different other things. Okay, so at this stage, we have our VMs. Now we are going to configure them. And we can do it with Ansible. Ansible is very well known, and it was historically used more for Linux machines. But since version 2.8, I believe, they have a really great support for Windows. So typically, they have support for WinRM, It's the protocol. It's one of the protocols that allow you to execute code remotely on a Windows machine. And you can use it with Ansible to run some provisioning command on the machines. You have a bunch of authentication options. And Ansible has a really nice Windows support that you can use both for servers, for workstations, and you can do all sorts of things from changing the registry, creating a domain, some Active Directory users, groups, you can change the firewall and all these kind of things. So there is another option than Ansible, and it's PowerShell desired state configuration. The reason why I didn't use it is mainly because I'm not familiar with it, and because I see a lot of ranting, for instance, from Adam Chester. He's a guy who does a lot of security and infrastructure as code, and I saw him ranting on Twitter about DSC a few times. So that's also part of the reason why I stick to Ansible. This is what a very minimal Ansible playbook looks like. You have a set of tasks, and each task has a name and a module. And in the module, you have some parameters. So in this case, we are creating a Windows domain, Christophe.lab, and then we are going to make sure that the domain control this for the first time is going to take a bit of time because the domain is going to be created, the machine is going to reboot and everything. And if we rerun it afterwards, it's going to be very fast because Ansible will see that the domain is already created, that the state that we wanted is already reached. So it's not going to do anything at the second run, basically. How it all fits together. So you have Azure, you have the Azure API. We are going to use Terraform to create the resources. So Terraform is going to hit the Azure API, and that will give us some VMs, as well as virtual networks and all kind of things. Once we have those, Terraform is going to run Ansible, and Ansible is going to configure these virtual machines via WinRM. So that's kind of how these two things fit together. So we are talking about infrastructure as code, but if we have code, this means we also need to test it, right? So how do we test it? There are a few options. One of them is called TerraTest, and one of them is called InSpec. So InSpec is a compliance as code, policy as code framework built by Chef, but that you can use totally independently. And it supports a lot of public clouds and a lot of different things. So essentially, you write your test in a Ruby style, and then you can apply them to make sure that the infrastructure that you built matches what you expect. So this is an example of how you can write a test to check that an Azure virtual machine in the resource group AD hunting lag named domain controller was created. And then we do all sorts of checks. We ensure that it exists, that it's created in the correct region, that it has the right name and tags. We can do the same for all the resources that we expect to see in Azure. And then we can run this against our Azure subscription. And InSpec is going to check all these points and make sure that what we have in Azure is what we expect. We can do the same more at the domain, like at the Active Directory level, because this is only for the Azure resources. We can do the same by running command on the domain controller. For instance, here we are going to check that the three users, Danny, Brent, and Karen exists in our domain. And we can do the same for groups, for group memberships, for software, and all these sorts of things. So in this case, we would run the test against our domain controller via WinRM, and InSpec would run the command on the domain controller or on any machine, and it would make sure that what we expect is indeed correct. So how do you use InSpec in a kind of continuous integration fashion? First, you have a CI pipeline, something like GitLab CI or GitLab Actions, Circle CI. And then you're going to run Terraform plus Ansible. And at the end of this step, you're going to have a full lab. So you have your full Active Directory lab ready to use. Then we're going to run InSpec. against the Azure API, just like we did before. And this will allow us to confirm that the resources are there, that we have the right VM, the right networks, and these kind of things. Once we have this, we can go a bit more granular, and we can check if we have the right users, the right groups, if we have the right features, the right programs installed on the machine. And after that, we can just burn the lab down. So typically this would take a bit of time because it's end-to-end testing, but it's nice because it allows you to have quite strong confidence that you didn't break anything when you add new features or when you review pull requests from contributors. All right, so now that we have the use case and the how, I'm going to discuss a bit about a tool that I've been working on in the past few weeks. It's called ADAS. The name is not really original. And it's a tool that allows to create customizable Active Directory labs in Azure. Just to clarify on the Azure Active Directory versus Active Directory in Azure. So Microsoft Active Directory, sorry, Azure Active Directory, it's a Microsoft service which is basically an identity provider, and it's not at all deploying Active Directory in VMs in Azure. And this is kind of confusing. So ADAS uses exactly what we saw before, Terraform and Ansible to create the labs. It's a bit more opinionated, and it has some features that are quite relevant for threat hunting and if you want to build detections. So it has Windows event forwarding setup, meaning that you have the workstations that are sending the logs back to the domain controller, which is aggregating them. You have Sysmon installed everywhere. You have Kibana and Elasticsearch for storing and querying the logs. And you have audit policies that are pre-configured. Because typically when you have a Windows environment, you need to set a GPO or a local security policy to have the logs that you want. Another feature that I put a bit of work into is the ability to have a domain that you can customize even if you are not familiar with Terraform and Ansible, because that can get a bit hairy. So we have a YAML file where we can define all sorts of parameters of our domain, things like the users that we want, the name of our lab, the groups, and also the list of the workstations that we want. So if we just want a simple environment with 2 workstations, it's fine. If we want 5 or 10, maybe with different users in different groups that are local admin of different machines, we can also do it. So how does it compare with other tools? The 2 main other tools that I know of are Detection Lab from Chris Long and Splunk Attack Range by Splunk. And so the main difference, you can see this table in the README, but the main difference is going to be the bring your own license of Windows 10, because Detection Lab and Splunk Attack Range, they use AWS or local VMs, so you need to have your own license. Whereas in Azure, it's included in the cost that you pay for the hourly VMs. And also the logs management, it's managed by Kibana Elasticsearch for ADAS, and with the other ones, it's Splunk Enterprise, which is a very nice tool, but it's not free. And on the feature side, I'm also looking into adding OS Query and Fleet and an IDS to match the feature set of Detection Lab. So I'm not going to praise the demo gods. So we are going to have a short demo, but it's going to be pre-recorded. Obviously, the demo is cut a little bit. So the whole demo would take approximately between 15 and 25 minutes, depending on Azure goodwill. I have cut it to make sure that it doesn't take this much time. All right, so we have our domain configuration file. We're going to create a domain called hunter.lab. We're going to have a DC named DC1, domain admin that we call hunter. We create a bunch of users, Christophe, Brent, Danny, Karen, and then we're going to add 2 workstations, Christophe WKS and Danny WKS, with respectively Christophe and Danny as local admins, and we disable the Windows firewall. All right. So now we just hit Terraform apply, And what Terraform is going to do is to show us the resources that it plans to create. So in our case, it's going to create everything because we didn't run it yet. It's going to create the workstations, the networks, and everything. And once the resources are created, Terraform is going to run Ansible against the virtual machines in order to configure them. As we can see here, it's running Ansible. And once this is done, we have a nice output where we can see the public IPs of all our workstations, the command lines that we can use to directly RDP into our workstations and domain controllers. And so this is automatic. We can just go in Kibana. We can check out what kind of logs we have. All right, so as we can see, we already have all the logs from our Windows environment, and we can already query it. And what's nice about it is that it's totally automatic. So you just spin up the lab and you have a Kibana instance totally ready to query with the logs from the workstations, the domain controller, and you have the logs from Sysmon and the built-in Windows event logs as well. So that was something I really wanted to have because it's definitely the feature that I use the most. So it makes sense that it's automated. So now let's RDP into a workstation to see what it looks like. We have a clean Windows 10 install, which is already domain joined in our domain that we call hunter.lab. So it's already domain joined, everything is installed on it. Right, now we can do the same for the domain controller. So we have a Windows Server 2019 host with Active Directory domain services enabled. And we can see that it's also acting as a log collector and that the workstations, they are sending the logs to it. So that's it. Basically, we can see that everything is automated, and that's really the goal. In terms of next steps for this tool, so I'm currently working on the inspect CI pipeline, and I will probably be running it via GitHub Actions. So this is work in progress. I also want to investigate how we can make Ansible playbooks faster. Typically, there are some things that I think we can do with using asynchronous tasks. For instance, we don't have to wait that Sysmon is installed in order to install another tool. So make things a bit more asynchronous. And there are also three main feature proposals that have been upvoted. So one is to install OS Query on all the workstations and provide a fleet server, which is essentially a centralized tool that allows you to run OS Query on all the machines. Another one is to add a Suricata IDS that would send the logs to Elasticsearch. And I think this is really a good idea because it allows you also to see the network view of some attacks and not only the host-based view. And for instance, Suricata, it has quite a lot of detection rules specifically for Active Directory kind of attacks. I think it has one for NTLM relaying and these kind of things. And the last one is to pre-install Invoke Atomic Red Team on the workstations. Atomic Red Team is a framework developed by the Atomic folks. And basically, it allows you to run very granular tests for very specific attack techniques in order to test your defenses and to build up some detection rules. So these are probably going to be the next features. In order of usage, it's quite simple. You start by cloning the repository. You install the dependencies needed for Ansible. Then you authenticate to Azure. The first time, this is going to bring up a web page from Microsoft. Then you initialize Terraform. It's going to download the modules if you run it for the first time. Then you just hit Terraform apply and you're good to go. So I think we have a bit of time left. So in terms of cost, it's estimated that with 2 workstations, this is going to cost approximately 33 cents per hour. So I would say it's relatively cheap if you run it for a few hours and then you destroy it, which is the instant. And it gets pretty expensive if you start to leave it running continuously. And bonus slide 2. So if you are a bit familiar with the kind of DevOps infrastructure as code world, maybe you know about HashiCorp Packer. And I just want to provide a bit of context about why I didn't use Packer for this project and also how Packer works. So Packer is a tool that allows you basically to build a base image for a lot of different platforms, including Azure. In the context of Azure, how it's going to work is you're going to use it and it's going to spin up a virtual machine. Once the virtual machine is created in Azure, Packer is going to be able to run Ansible against this machine to configure it. So after this step, we are left with a VM running in Azure, which is properly configured. Next thing Packer is going to do is going to capture a snapshot of this VM and to save it as a base image in Azure, which is called a managed disk image. And it's the new, it's kind of a new way to do base images in Azure in comparison to the old VHD format. And once you have it, Packer is going to destroy your old VM. So what we are left with at the end of Packer is a snapshot basically of a VM, which is already pre-configured. So if it's a Windows domain controller, you're going to have all the domain created, you're going to have the groups, the users, and all these kind of things that are already ready. And the way you're supposed to use that is then to use Terraform and to instantiate this image using Terraform. So you say you use Terraform to instantiate a VM from this base image, and this is kind of the concept. So I got some questions around why I didn't use Packer, and these are the main reasons, the main challenges. So first, building a base image with Packer is quite slow. It takes from 25 to 35 minutes, depending on the goodwill of Azure. And after that, you still need to instantiate the lab. So instantiation will be faster, but it means that it's still much slower the first time. The second reason is that storing managed images in Azure is not free. I think for the 128 gigs of Windows Server machine that you need to use, it costs something around $33 per month per machine. So it's not cheap. And the last thing is that you have the challenge of what do you want to include into the base image, which is going to be much harder to reprovision, and what do you want to keep at runtime provisioning. And so these three challenges are the reason why I didn't publish yet a Packer file for that, because I want to keep it simple. But I will probably also work into providing this if there is some interest for it. Thanks a lot. So this is the link to the project. The contributions and the feedback, the bug reports, the ideas are very welcome. I'm very happy to discuss on Twitter or via email about the project or any suggestion. And there's also a more detailed write-up that I did on my blog, where you can basically see a bit more of the thought process. You can see more of Terraform code and these kind of things if you are interested and if you want to learn more about how this all fits together.
Cool. Well, thanks for your presentation. It's quite neat. It's quite neat. I like it a lot. A quick question. At some point, you mentioned inspect and what was the name of the one? TerraTest, I think.
Yes, the other one was TerraTest. Yeah.
So, what did you end up using? Inspect instead of TerraTest? I missed that part.
Yeah, so
and what's the difference between the two?
Yeah, sure. That's a good question. So actually, TerraTest, I'm not familiar with it, and I believe you have to write quite a lot of Go code.
So it's also in Go. It's not a YAML file, or
yeah, it's in Go, so it's compliant as code, but it's in Go. And personally, I don't know anything about Go, so I think the learning curve is a bit steeper if you are not used to Go. But it's definitely something to look into as well.
Yeah, I mean, definitely, because even those things are like, they look kind of obvious, and then you start digging in it, and you're like, oh, wow, actually, there's more layers to it, you know, like, another question for me. So what's the difference between Ansible and Terraform? Because Ansible, like first time I saw it, I remember it was when I deployed an Algo VPN thing with it. I was like, oh, wow, what do they do the deployment? I was like, oh, holy shit, you know, this is crazy. And then people were kind of like talking about Terraform, but then I was a bit confused between the two. Like, if you can explain that to me.
Yeah, that's what I like to call the DevOps symptoms, because like you have so many tools that do a bit of everything, and then you're not sure how they fit together and what you can use. Or so basically, there is partly some overlap between Terraform and between Azure. There are some things that both can do, but I would say that generally, Terraform is used to create sort of public cloud resources, when Ansible is going to be more targeted at configuring them at runtime. That's
So
only
Terraform would
partly
be
true.
before, when you create like your VM type of thing, more like, or?
Yeah, I mean, at least that's the general usage that I see, is that you use Terraform to create your resources, maybe in a public cloud, and then you're going to use something else, maybe Ansible, to configure it. So maybe if you want to create, I don't know, Nginx instance in Azure, maybe you are going to use Terraform to create the VM and the network, and then Ansible to install the packages and to apply your Nginx configuration and these kind of things.
Okay.
But there's also some things that you can do with Ansible related to that. And you have other ways also with Terraform. With Terraform, you can also run kind of bash scripts or other kind of provisioners. Yeah.
I see. Yeah, because if I remember correctly, one of the things I read about Terraform is, well, instead of having to have like one template for Azure, one template for AWS, one template for GCP, one template on premise, you can just have one Terraform template and just select your cloud provider, right? And then you don't have to rewrite the logic, correct? Or it's not exactly true?
Actually, as far as I know, Terraform is not cloud agnostic, in the sense that you can write some code that is going to work for Azure, some other code who is going to work for Google Cloud, and some other one
so
for
it's not
another
cloud
cloud.
agnostic, huh?
It's not cloud. No, it's not, because you need to rewrite the code, but you can use it to work in a lot of different clouds, and you can also use it to provision things like Kubernetes clusters, or things that are much more specific, like Cloudflare configuration, also these kind of things.
That's pretty cool. Yeah, because from what I read at some point, I thought it was cloud agnostic, and that's kind of like what I remembered about it. I was like, oh wow. But if you say it's not exactly like cloud agnostic, that would make sense. Yeah.
I don't know if they have some features around that. Maybe it would make sense to be able to, as you say, to say, I just want a VM with 4 gigs of RAM in this network exposed to the internet, and maybe to have a layer which would do the conversion between this high-level format and then something more low-level for a cloud provider. I'm not sure if that exists. I guess it would be quite hard to abstract all the differences between the cloud providers. But if you know something about that, it would be super interesting to know about. Yeah.
To be honest, I don't have any experience with it. That's what I was asking. So like, I'm just looking at the code now. So for instance, like like for instance, like Kibana and Elasticsearch, that's done in Terraform, right? I'm just checking the code now. Like it's on the screen. It's not in Ansible, right?
So let me check the screen. So the creation of Elasticsearch and Kibana VM is done with Terraform, and then all the installation of the packages, the configuration is done with Ansible.
Oh, okay, because Terraform. Oh, okay, that was just for the VM, I guess. That makes sense.
Yeah.
Elasticsearch, Kibana. Okay, yeah, that's pretty cool.
And so if you check, there is one Terraform directory and one Ansible directory. So basically, in the context of this project, you can consider that anything inside the Ansible directory is for kind of runtime provisioning of the virtual machine. Things like configuration files and installing packets, setting the registry keys, or these kind of things. And everything in Terraform is basically Azure specific.
And is there a way, like, I mean, do you have to do that like manually, or is there like a kind of like an helper with like the cloud provider? Because I think like on Azure, for instance, you can export templates. So can you export a template and convert it into Terraform and then like clean it? Or you have to, it's probably better to write everything from scratch.
I'm not exactly sure. I think you cannot do it, but I will have to check. I know what you can do is to start managing a VM that you did not create with Terraform, to start managing it with Terraform, but you still need to write the code as far as I know.
I see. One question from the chat from Anne Tweety. Christophe, what Terraform provisioner did you use for Ansible and why?
Yeah, so I think, no, I didn't mention it in the slide, but there are multiple ways to do it. One way is to use the local exec provisioner of Terraform. And so with this provisioner, Terraform is going to run locally on your laptop a command once the resources are created. So in this case, what is going to happen is you're going to run Terraform apply.
Mm-hmm.
And when the virtual machines are created, Terraform is going to run locally on your laptop the Ansible command to provision them. There are a few more details in my blog post about it if you want to check out. Typically also there's the question of how do you locate the virtual machines that you want to configure without hardcoding the IPs because they are dynamic. And you can do it with Ansible with what they call a dynamic inventory. So instead of hardcoding an IP address, you say, I want to use any VM in this resource group that has this tag. And then you say, I want to apply this Ansible playbook to these machines. And this is what allows you to find them.
Yeah, like the blog post is actually like is pretty good. Like the way you're explaining like Terraform and Ansible, and it's quite well done. It's really well written too.
Thanks.
Yeah, well, thanks again for presenting. It was very interesting. Definitely gonna rewatch it tomorrow. And if you ever have like something cool also to present, don't hesitate. It was awesome. So thanks again, Christophe.
Thanks. Bye, Matt.
Take care.